Alrighty, good morning, everyone. Today is Wednesday, May 6th. I hope you guys had a good Cinco de Mayo. Let's go ahead and get started. Sorry, I'm a few minutes late. I had to get some breakfast ready for the kiddos. Hope you guys are doing well. I'm going to share my screen right now with the PowerPoint for today's announcements. All right, so today we're going to go to about 12:30 p.m. We're going to be talking about the new chapter on log functions. And actually, before we go through log functions, I'm actually going to do a review for the functions and exponentials. I know some of you guys had some questions on it, and we're actually going to go through a review of a quiz. So let me announce that in a second. So we're going to do the quiz review. There will be a quiz on functions and exponential, and I realized I might have given it to you, notified you guys a little bit last minute, so it'll be available all day today and all day tomorrow. So you have 2 days to take it, and of course it's unlimited chances. So it's on functions and exponential, that's a chapter that you guys just finished last night. Then we'll have a 10-minute break, and we're going to do student spotlights. If anyone wants to do a student spotlight, please chat with me and let me know that you'd like to do it. Make sure you send it to me. And group 8, I put group 6. I meant group 8. Paul, are you here by any chance?
Yeah, I'm here.
Okay, great. So are you ready to?
Yeah, I'm ready to share. Actually, I modified my PDF file, though. And if you want me to share it off my screen, I can. Otherwise, I sent it to you again in at Facebook.
Okay, either one is fine.
Okay.
I'll have you share around 11:10 p.m.
All right.
After all that, we're going to start on the new chapter, which is on log functions. So the homework is that today and tomorrow there will be a quiz on functions and exponentials. Again, it's going to be available all day today after our class. It's going to open up at 1 o'clock, and then it'll be available all the way until midnight tomorrow. And then we're going to start on log functions today. There's 14 topics, so I'd like you to do at minimum 7 topics by Sunday night. Right? So at minimum 7 by Sunday night. And then on Monday, we'll finish up log functions, but we'll just only finish half of it today. If you haven't sent in your student spotlights yet, feel free to do so. DLAs and SLAs, remember at the end of the semester, you need 5 of them completed. Upcoming events, group 9 presentation is next week. So let me know if you guys want to do it on Monday or Wednesday. Continue sending in the student spotlights. We're going to have ConferZoom on Monday at 1 p.m. and on Wednesday at 10 a.m. Monday, we're going to finish the log functions. Wednesday, we're going to review for a quiz. And there will be a quiz next week on log functions. This is kind of tentative right now, so don't, I want to see how far we get in the lecture. So this is a little bit tentative, but I just want to let you guys know there'll be a quiz sometime next week, a little bit tentative here. And also note that the Alex gradebook is all up to date. I know some of you guys have been sending me questions about, hey, have you gotten my SLA yet, etc. And I kept saying, you know, I'm waiting for the Math Success Center to send me the list of students who did it. Well, they sent it to me, and I've updated all your SLAs, all your exam corrections, all that. So if there's anything that's missing, if you're looking at your grade book on Alex and say, hey, I didn't get credit for this or that, contact me and send me the appropriate documentation. Remember, Garrett's tutoring on Discord is between 12 to 4 p.m. Monday to Thursday. All you do is you just click on this website, this link here on your phone or on your computer, and it'll take you right there. Okay, my YouTube videos are always up. Great. Okay, at this point, does anyone have any questions about anything? Any questions on homework or topics? No questions?
I kind of have a question. For the homework that is due Thursday,
Okay.
is there a way that there could be an extension besides the whole waiting for catch-up days?
What homework is due on Thursday?
Didn't you say that the Alex homework was due Thursday?
No, the quiz is due Thursday.
Okay.
Yeah.
Yeah, because I didn't attend class on Monday, and I had a very stressful week, so I'm very behind.
Well, why don't you chat with me privately about those things? So if any of you guys have any private requests, please do so. Yeah, chat with me privately about that, and I'll work with you. There was homework that was due yesterday, so that might be what you're talking about. The homework that was due yesterday is on functions and exponentials. The quiz is going to be today and tomorrow. So that's what's next. But any of you guys have any situation where you guys need a one-day extension or whatnot, let me know and I'll work with you guys about that. Okay, so feel free to private chat with me on the chat room here or on Facebook, or you can just do it here since I'm online. Okay. Alrighty, so at this point, I'm going to share my screen and we're going to go over a quick quiz. I'm going to go over the quiz that you guys will be taking. Second. Mommy. Hi, give me 1 second.
But Mommy,
Shh.
Mommy, I want to tell you something.
Okay, give me 1 second. Wait.
That is the problem.
What?
So I want more eggs and meat and cheese and I want butter on my bread.
Okay, give me 1 second. I'll come out and get you guys more butter, more eggs. Sorry about that. All right, so here is, can you guys see that?
Yes.
Okay,
Yeah.
this is one version of the quiz. Of course, the quiz that you guys have on Alex is going to be a different version. So let's start off with, we're going to do it together, and I'm going to give you guys a chance to work on number 1 right now. So number 1 says the blue graph is this. The blue graph is square root of x, and the red graph is this. So we're going to need to shift this graph. So let me give you a chance to kind of work on that right now. Go ahead and try shifting the graph, and what would happen to the function if you shifted it. So you want to write the g function. Let me give you guys a chance to work on that. And as you're working on that, I just need to tend to my kids for just a little bit, sorry. I'm going to put up question 2 as well in case you're finished with that. There's question 2. And you guys are welcome to chat with each other during this time. I'm going to just tend to my kids for 1 second. All right, so I heard some of you guys talking. Right, so starting from the blue, the F, and we want to move to the G, what direction do we need to move and how many units?
Like she said, I think it's square root x plus 4
Okay.
minus 3.
Okay. Yes, I'll give them eggs and cheese in a second. Thank you. Yes, so we moved 1, 2, 3, 4. We moved 4 units to the left, right? So when you move 4 units to the left, you're going to take the square root of x and then you're going to add 4 underneath the square root of x. Right? So inside the square root of x, so you're changing the input, right? The input square root of x is the square root of x plus 4. So when we move horizontally to the left, we add. When we move horizontally to the right, we subtract. So here we add 4 to the inside of x. Good. Square root of x plus 4. And then what else did you say, Anthony?
Minus 3.
Minus 3, right? Because we have to move 1, 2, 3. 3 spots down. So when you move down, you have to put minus 3 because downwards is minus and upwards is adding. So question 1, your answer should be what Anthony just said, square root of x plus 4 minus 3. So this x plus 4 is inside the radical, and the minus 3 is outside of it because the minus 3 is shifting it up and down. Shifting it down is particular, and the plus 4 inside the radical is shifting it to the left. Does anyone have any questions with number 1? All right, nice job with that, you guys. Okay, so now let's take a look at question number 2. So go ahead and add the functions, subtract the functions, and then this last one means multiply the functions, but put a 4 inside of it. Did anyone already finish these?
Professor, I have a question. Was this worksheet available online? Because I didn't see it.
Nope, this is just what I'm putting up right now. We're practicing for a quiz that you guys will be taking today or tomorrow. Yeah, I'm just putting it up right now. Good question, Jessica. Do you guys need more time with number 2?
Yes.
Okay.
Yes.
Okay, great. Thanks for letting me know. Alrighty, so for number 2, the first one, S plus T. Let me just call on a few people or anyone who would like to answer that question. S plus T, did anyone get an answer? What happens when you add these two functions together?
I didn't take it so long.
Because I'm working right now. Anyone get an answer for S plus
6x minus 3.
Great, and how did you get that, Ruby?
I put them next to each other and then I added 4x and 2x.
Great.
Oh,
So
yeah.
6x and then minus 3. Great.
Yeah.
Okay, what that Ruby did. 6x minus 3 would be the first one. So we just add them up. Part B, S minus T. Did anyone get an answer for S minus T?
Hey, she and me.
Negative 2x minus 3.
And can you explain how you got that, Anthony?
It was 2x minus 3 for the first part, and then I distributed the negative into the 4x, so that's negative 4x, and I got negative 2x minus 3.
Perfect, that's great. So negative 2x minus 3, right? Or minus 3 minus 2x, whichever one you want. Any questions about what Anthony did? All right, last but not least, how about S multiplied by T with a 4 inside of it? Anyone get an answer for that?
Is it 8x squared minus 12x?
All right, and how did you get that, Paul?
I distributed 4x with 2x minus 3.
Uh-huh.
So I multiplied 4x times 2x. I got 8x squared. Then I multiplied 4x by negative 3 to get 12x.
Great. So we get 8x squared minus 12x, right? Great. So what's one thing that you're missing? Does anyone know what Paul forgot to do?
Oh, I didn't. Do I need to factor that?
Not factor it out. Notice what is the input in this problem?
Oh,
4.
4, right? So now wherever you see your x, put a 4 instead. So when you put in 4, all right, when we plug in a 4, what do we end up getting?
80.
80? You guys agree?
Yeah.
All right, so let's check our answers. So let's look at number 2, and the answer is 80. All right, so number 2 here, here's the answer. Part A is 6x minus 3, like Ruby said. Negative 2x minus 3, like Anthony said. And then 80, like Paul started, and then the rest of you guys plugged it in, 80. Any questions on number 2? All right, perfect. Let's go ahead and look at number 3. So number 3 here is we're doing dividing now. So G divided by H, but you plug in 2. So in number 3, we could do what Paul did where we divide first or multiply first, whatever it is, and then plug in the number 2, or you could plug in the number 2 first. So you plug in the number 2 first into G, plug in the number 2 first into H, and then divide your answer G divided by H. So whichever one you choose to do is fine. And then part B is to find the domain, because as we know with fractions, there's a restriction for fractions. So let me give you a chance to do number 3. And if you guys want to move ahead, here's number 4 to do composite. But go ahead, work number 3 at minimum. Alrighty, so let's look at number 3 here. Did anyone get an answer for part A?
Would it be negative 24 over 11?
Okay, and how did you get that, Anthony?
Well, first I substituted 2 into the x's.
Okay, so substitute 2 in the x's.
And at the top I got 6 times negative 4. So that'll be negative 24.
Okay, so is everyone okay with that? G of x, if you plug 2 in here, you get negative 24. Is that what you said, Anthony?
Yes.
Okay, is everyone okay with that? Negative 24 for G of 2. All right, keep going.
And then at the bottom, it's 2 plus 9, so that's 11. So negative 24 over 11.
Right. Is everyone okay with that? Any questions? Negative 24 over 11 is the answer for part A. Any questions on that? All right, great. And then how about part B? Did anyone get an answer for that? So G divided by H is a fraction, right? So 4 plus x plus negative 6 plus x divided by divided by 9 plus x. So if you're doing division, the fraction has a denominator of h. The denominator is 9 plus x. So what is the restriction with fractions? What can you never have in the denominator?
0.
Right, you can never have a 0 in the denominator. So 9 plus x is the denominator. If you set this equal to 0 and you solve for x, what will x be in order to make this a 0?
Negative 9.
Right. Is everyone okay with that? So the denominator, h of x, will equal to 0 if x is negative 9. So therefore, we cannot have a negative 9 in the domain. So it says find all values that are not in the domain, so x cannot equal to negative 9. So if I look at the answers down here for question number 3, values that are not in the domain, negative 9. Part A, negative 24 over 11, as Anthony said. Does anyone have any questions with number 3 that needs any clarification? All right, in that case, let's go ahead and move on to number 20, or to not 24, to number 4. So now we're going to do composite problems. So composites are a little bit trickier. So remember, the first one is the outer function. The second one is the inner function. And whenever you're doing composite functions, you work on the inner one first. So you plug negative 1 into the inner function. So in part A here, you're going to plug into P. You can plug negative 1 into P. And then whatever answer you get, then you plug it into the outer function, which is Q. So you feed your answer into Q. Part B is the opposite, right? The inner function is Q and the outer function is P. So you first plug in negative 1 into Q, and then you feed that answer into the outer function. So let me give you guys a chance to do that. All right, let's look at number 4 now. So number 4, part A, Q composite P with an input of negative 1. Can anyone walk me through with what you did? And it's okay to get the wrong answer too, by the way, so don't feel pressure. Go ahead.
So this is Paul. I got Q. Do you say Q composite P?
Yep.
Okay, so for that function, I plugged in the negative 1. So I wrote 2 parentheses, negative 1 plus 2 to get the inside part of the function, and I ended up with Q then being Q times 3. And then I plugged 3 into the Q function and squared it and got 9.
All right.
I didn't say that very correct, but I think I got it right.
I think you explained it right, but I'm not sure how you got the numbers. So let's first start off, Paul. So thank you for sharing. Let's first start off with Q composite P, right? So the first thing we do is we look at P, the second function, right?
Right.
You plug negative 1 into P. So when you plug -1 into P, by the way, can you guys see my arrow in the screen by any chance?
Yes.
Yeah, you can see my arrow? Okay.
Yeah.
All right. So when we plug -1 into here, 2 times -1 plus 2, what would it give us?
0.
0. Right. So 2 times -1 is -2 plus 2 is equal to 0. So I think you got -3 by mistake, Paul, but it should be 0.
Yeah, I see where I did wrong. I actually just calculated it wrong, but I wrote it correctly, so. I
Okay,
understand.
got it. But then I heard your second step, which was correct, which is to plug that answer into the first function, which is Q. So here we get 0, and then you said now plug it into Q function, which is good, which is correct. So if you plug 0 into the Q function, what do we get when we get 0 squared?
0.
0.
0. Perfect. Good job. So the first answer is 0. Great. How about the second question? Anybody help me out?
First you substitute -1 into Q.
Okay, so we plug it into the second function, the inner function. Okay.
So that'll be -1 times -1 would be 1. And then you
Get the
substitute,
positive one. Okay.
yeah. And then you get the +1 and substitute it into P.
Mhm.
So that'll be 4.
Good. So you plug. So is everyone okay with getting a +1 for here?
Yeah.
Okay, good. So the inner function we get +1, then we feed it into the outer function. Right. And the 2 times -1 or 2 +1 plus 2 is, what did you say it was, Anthony?
For the final answer?
Yeah,
4.
4. Okay. So the second answer is 4. So we plug 1 in here, we get 2 times 1 plus 2 is 4. Does anyone have any questions with that? Let's check his answer. So number 4 here is 0, and part B is 4, which is correct. Awesome job, guys. Great job explaining it. Again, at any time you guys want to ask a question or not sure how, please let us know. This is what this time is for, right? Because you'll be taking this real quiz later, and I want you to be able to understand how to do it. So now number 5 is asking us, is this 1-to-1? And the answer is just a yes or no. What test are we doing to do 1-to-1? What do we do to test it out?
Horizontal line test.
Right, the horizontal line test. So we're going to draw horizontal lines. And if it touches it at more than one spot, is that a yes or a no?
No.
No, right? So it touches more than one spot, then the answer is no. So for part 5, we'll do this together. Let's imagine a horizontal line, horizontal line, horizontal line. Is the answer yes or no?
No.
No. And why no?
It passes more than one time.
Right. So Jennifer says, because it passed it more than one time here. If you drew a horizontal line here, touch it twice. Everyone okay with that? Question 5, part B, yes or no?
No.
No, right? You draw a horizontal line, touches it twice. Good job. Part C,
No.
no as well. Everyone okay so far?
Yes.
Part D,
Yes.
Yes.
yes, good. Yes, it is 1-to-1 because you only touches it once when I draw the horizontal line. Good job. Part E, this is tricky.
Yes.
Yes.
And why is it yes?
Because
The -5 is not included.
Circle.
Right, there's an open circle, good. So if I drew a horizontal line here, the -4, or this open circle is not included. So it actually only touches it at one point there, good. So the answer is yes, it is 1-to-1 because it only touched at one point when we drew this horizontal line. Nice work. Last but not least, how about this one?
Yes.
Yes, it is 1-to-1, right? Horizontal line, horizontal, 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 only touches it once. So the answer is yes. Great job. All right, number 6 and 7, I'll leave this on the screen. So find H inverse and state the domain and range of H inverse. So this is where this had the 4 steps that I had you guys do. Remember, inverse means to reverse the X and Y's. So this is h of x, so you can consider this as y is equal to 7x over 2x minus 9. Now you're going to switch the x and y's. So when you switch the x and y's, this should become x is equal to 7y over 2y minus 9. And then you're going to solve for y. And then you're going to find the domain and the range of H inverse. So review your notes on this if you don't remember. We covered this on Monday. I'll give you guys a few minutes to work on this, and I will pause the recording while you guys are working on it. And feel free to talk with each other and ask each other questions or say things if you guys want to interact with each other. Alrighty. Let's take a look at this. If any of you guys want to share your screen, you're welcome to explain what you did. Or actually, maybe I should just share my screen then. So I'm going to spotlight my video on my phone camera. Right. How do I change this? Okay. So this is what we did on Monday, where we talked about the 4 steps. The first step is to rewrite it, where you have y is equal to the function. Then you switch the x and y's, and then you solve for y. And once you solve for y, that becomes your H inverse. So in this problem here that we just did, where is it? So in this problem here, we have h of x is equal to 7x over 2x minus 9. Can anyone walk me through what we were supposed to do?
Isn't the first step you have to equal it to y?
Okay, good. So we set it equal to y. Great. Second step?
You switch x and y's.
Great. So we switch the x and y. So those are the easy steps. The first 2 steps are very easy. Switch the x and y's, right? Because it's called inverse. Okay, and then the next step?
You just solve for x
Not solve for x, but solve for
or y.
Good. So this is a fraction. How do we solve for y? What should we do first?
You multiply 2y minus 9 to both sides.
Yes, we multiply 2y minus 9 to both sides. So you multiply on the left side and you multiply on the right side, because to get rid of fractions, we multiply the LCD, right? The LCD is 2y minus 9. So here we multiply 2y minus 9 to just cancel out. So you end up just getting 7y. Perfect. Now what?
Don't you distribute x? Oh wait, actually,
You actually,
wait, you do, right?
yes.
Yeah, distribute x.
Good. So we want to distribute the x because we want to get rid, first we got rid of fractions, now we want to get rid of parentheses. So we distribute the x, what do we get?
2xy minus 9x.
Equals 7y, okay. Now what do we do? Here's my y and here's my y. What do I do?
You subtract 2xy to both sides.
Great. So we bring all the y's to one side of the equation, right? So I'm going to subtract 2xy, good, to both sides, like you said, because we want to bring all the y's to one side of the equation. So we get 7y minus 2xy. So all of the y's are on one side of the equation now. What do we do next?
We factor out the y.
Yeah.
So we factor out the y. So we factor out the y. What do we get inside?
7 minus 2x.
7 minus 2x. So when you factor out the y, is everyone okay so far? Any questions? All right, and then what do we do after that?
Divide 7 minus 2x.
Good. So we divide by the coefficient of y. We want y to be sitting by itself, right? So this whole thing, we're going to divide both sides by 7 minus 2x. Good. So as a result, we end up getting y is equal to negative 9x over 7 minus 2x. Is that how we write our answer? So they're asking us for H inverse, right? This is H. We want H inverse. So instead of saying y is equal to that, we say H inverse is equal to negative 9x over 7 minus 2x. And that becomes our final answer. Any questions? All right, and then the other question they're asking us is to find the domain of H inverse. So to find the domain of H inverse, what would the answer be in this problem? So here's H inverse. What are the, H inverse is a refraction. What's the restriction of a fraction?
You can't have a 0 in the denominator.
Right, so we can't have a 0 in the denominator. What's going to cause us to have a 0 in the denominator? I'm going to bring the 2x to the other side. I'm going to add 2x to the other side. I'm going to divide both sides by the coefficient of x, which is 2. So x cannot equal to 7/2. So x cannot equal to 7/2. And they said to write this in interval notation. So without repeating Monday's lecture, you guys could go back and look at Monday's lecture. Writing this in interval notation is from negative infinity to 7/2, union 7/2 to infinity. So I went into a lot of details with that on Monday, so you guys can look at that. That would be the answer. That would be infinity right here. It's infinity, sorry. Any questions? And then last but not least, they asked us for the range of H inverse. How do you find the range of H inverse? What are you supposed to look at?
Isn't it the original problem?
original.
It'll be the domain.
Right. So the range of H inverse is looking at the original problem. The range of H inverse is exactly the same thing as the domain of H. So again, I'm not going to redo the lecture from Monday, so you guys can look back at that. But the domain of H. So what is the domain of H? What are the restrictions for this H problem?
It can't equal to 0.
But the denominator cannot equal to 0. So 2x minus 9 cannot equal to 0. So without just making this go a little bit faster, if I add 9 to both sides and 2x cannot equal to 9, and then divide both sides by 2, I get x cannot equal to 9/2. And then to write that in interval notation, it's negative infinity to 9/2, union 9/2 to positive infinity. So that means the domain is every single number except for 9/2, and that's why it's an open bracket, because it does not include 9/2. Any questions on that problem? Alrighty, so let's go ahead and I'm going to go ahead and share screen and go back to the quiz again. So going back to the quiz now, number 7 and number 8. Number 7 is to go ahead and graph this. So looking at this problem real quick, based on what we talked about on Monday, is this an exponential growth or an exponential decay?
Growth.
Try again. So if you guys recall, when you have this, an exponential function is a number raised to an exponent. I mean, raised to a variable. And if the number, the base, is bigger than 1, then you're gonna have a growth. You're gonna have a graph that looks like this, like grows. If it's bigger than 1, but what if it's less than 1? What if it's a fraction? What would it look like? It'll be decaying, looking like this, right? It'll be going down sharply. Instead of going upwards sharply, it's decaying sharply. So let me give you guys a chance to go ahead and plug. Remember what we did on Monday? We plugged it into a table of data where we had the x values and the y values plug in points. Let me give you guys a chance to work on that. It shouldn't take too long. So go ahead and write down that problem. And then number 8, I'd also like you to work on number 8 right here as well. So this is a word problem with compounding semi-annually. And remember, we needed a formula for that. So let me give you guys a chance to work on that. I'll pause the recording, and I see Garrett on, he's officially on right now. So I'm gonna put this on pause. If you guys need any help, go ahead and talk to each other throughout the pause, and Garrett can help you guys out. Alrighty, so let's look at number 7. If you guys graphed it right, I'm just gonna show you guys what it looks like. If you graphed it correctly, you should have these 4 dots here. 0, 1 is 1 point. At -1, it's somewhere up here. At -2, it's somewhere up here. At 1, it's somewhere here. And at 2, it's closer to 0. So as you can see, it's an exponential decay because the base is a number that's a fraction between 0 and 1. So it's basically just plotting points in there. Does anyone have any questions with number 8 or number 7?
No.
All right, so number 8, the answer is $12,005.84. $12,005.84. Can someone tell me what the formula was that you used to get $12,005.84? What was the formula you ended up writing out?
Instructor, is a formula that A equals P parentheses 1 plus R over N parentheses NT?
Perfect. Yes. So A, and actually let me go ahead and stop the share. I'm going to focus it on my thing here. So right. So can you say that formula again?
Sure. A equals P
Right.
parentheses 1
Good.
plus R over N. And then you close the parentheses and T.
Great. Great. I'm sorry, who's speaking right now?
Melissa.
Melissa. Great, Melissa. And what did you end up plugging into these numbers or this formula?
Next to the T is an N, right? At the end?
Sorry, NT, yes. Great. And then what values did you plug into here?
Yeah, for the P, I plugged in the 8,000.
8,000 for P.
And then 1 plus, and then R, it's 0.14.
Great. 14.
Over 2.
Great, because it's semi-annually.
Yes.
Semi-annually, so it's twice a year. Good.
And for the N, the number 2.
Okay.
And T3, the number 3.
So 2 times 3. Great. Great job, Melissa. Is everyone okay with how she got this? Any questions with any of these values here? All right, so again, the 14% became 0.14. The N is how many times it's compounded a year. Since it's semi-annually, that's 2 times a year, right? And then that number of years is 3. Okay, so go ahead and plug this into your calculator. So you should plug this in first to your calculator. Raise to the 2 times 3. 2 times 3 is just 6. So remember, order of operations, do the parentheses first, and then raise it to the exponent, and then multiply it through. So if you don't do it in the right order of operations, you'll get the wrong answer. So make sure you do the parentheses first, then the exponents, then you multiply it out. And then when you do that, you should get the answer of $12,005.84. Does anyone have any questions? No questions?
I have a comment.
Yes, go ahead, Derek.
Also, depending on your calculator, you may be able to punch this in one go. Also, make sure that when you're doing this calculation that you're not rounding in between steps. So like if you do the parentheses, don't round there. When you add the exponent, don't round, right? Use as many decimal places as your calculator gives you, because you may get a slightly different answer than what the Alex will accept. I know there are some students working on it from another class, and they're all confused because like I punched in those numbers, but they were rounding halfway through, and they were getting different numbers.
Right. So good point, Garrett. Yeah. So whenever you're computing these answers, every time. Shh, give me 1 second. No, wait. So whenever you're
surprise for you.
You're a surprise for me? Okay.
Yeah.
Thank you. Give me 1 second. Okay?
You can open it when you're done. Okay?
Thank you very much. Give me a few minutes.
Okay, I'm gonna finish it.
All right. So like Garrett said, because every time you round it, we call it a round off error. Because notice every time you round some part of your answer, you're going to get a little error because it's not exact. And if you keep doing that every single time, your error is going to be really big at the end. So therefore, you don't want to round your answer until the very last step. So here in this problem, so let me just show you what Garrett's talking about. So if I did 1 plus 0.14 over 2, so I'm with parentheses 0.14 divided by 2. Oh, that ends up giving you a nice answer, -6. I raise it to
a negative instead of a point.
Oh, sorry. Thank you. So 1 plus 0.14 divided by 2, and I put parentheses around the fraction. I get 1.07. If I round it off, I would probably get something different. If I round it to 1.1, then I would get it. My answer wouldn't be as accurate. I'm going to keep the answer and I'm going to raise it to the 6th power. So I'm not going to round that. I'm going to leave it as is, raise it to the 6th. So with my calculator, I just put caret 6 because it takes the previous answer and then it raises it to the 6th, and I press enter. And I'm not going to round that answer. I'm going to keep it in my calculator and then I'm going to multiply it by 8,000. So what I do is I don't have to retype it. I just put times 8,000. So without retyping it, the answer shows up. And I press enter, and what do you know? $12,005.84. So that's what Garrett means about don't round in between. Just wait until the very end to round your answer. Thanks for bringing that up, Garrett. All right, any other questions about this quiz that you will soon be doing? All right, so that quiz is going to be available after class today at 1 o'clock. It's only 8 o'clock. You read it all, so hopefully it'll be easy for you to do it again. You have unlimited tries. You can do it today and or tomorrow, unlimited tries. And whatever you see on a quiz, you'll see on the exam as well. I highly recommend that you learn how to do it now so that you don't have to wait until the exam and start stressing out. I'm going to give you guys a 5-minute or 7-minute break at 11:22. When we come back, Paul will do his presentation. And if anyone wants to do a student spotlight, let me know as well.
I just have a quick question.
Yes.
For the quiz, will it be like only on these 8 questions?
Yep.
Okay, thank you.
Welcome. Alrighty, welcome back, everyone. At this point, I am going to have Paul do his group presentation, even though it's group. It says group is him. So, Paul, you're up.
All right. So my topic was I just wanted to talk about density. I didn't find specifically how density is defined as algebra, but every time I did, I was looking up how algebra was used in astronomy, and density was like the #1 result. So I decided to cover it. So this is a guy named Archimedes. It's a story of a Greek mathematician named Archimedes who lived around 250 BC, the king of Syracuse. Hold on a second here. The king of Syracuse, where Archimedes lived, thought that he was being cheated by the metal craftsman who made his golden crown. The king called Archimedes to him and gave him the task of finding out whether the craftsman had placed some of the gold in the king's crown with silver. Archimedes thought about the problem while taking a bath. As he entered the bathing pool, he noticed that the water spilled over the sides of the pool. He realized that the amount of water spilled was equal in volume to the space that his body occupied. This fact suddenly provided him with a method for finding out if the king's crown was made of pure gold. It also said that the king had made a point to tell him that he couldn't alter the crown in any way, so he couldn't like melt it down or anything to find out if it was a different substance. So let's see. Because of the amount of silver occupies more space than an equivalent amount of gold, Archimedes placed the craftsman's crown and a pure gold crown of the same mass in 2 tubs of water. He found that more water spilled over the sides of the tub when the craftsman's crown was submerged. It turned out that the craftsman had been cheating the king. So the legend has it that Archimedes was so excited about his discovery that he ran naked through the streets of Syracuse shouting, "Eureka, Eureka," which means "I have found it." So that's the history on it. Here's some more information on mass and density, how they're related. Am I able to scroll this myself? Okay.
No, only if you're sharing it, can you scroll it down? Do you want to see yours?
No, that's okay. If you could just keep scrolling, I appreciate it. So I got the difference between density and mass. Mass and density are 2 commonly used physical properties of objects in physics that are very similar and share close mathematical relationship. Mass and density should not be confused with weight. Weight is the force of gravity that acts upon an object's mass. In the absence of it, objects have no weight. And weight is measured in units called Newton, and we interpret that into kilograms or pounds. Can you scroll up, please?
What, Paul? I totally forgot to ask you. Is it okay that I record this and share this?
Oh yeah, that's fine.
Okay, good. I want to make sure.
No problem. Can you scroll up a little bit more here? All right, so mass is the measure of how much matter there is within an object, typically given in grams. Mass is not affected by gravity, so a given object would have the same mass on Earth as it does in outer space. And they measure mass in the units of kilograms. Volume is defined as a 3-dimensional space enclosed by a boundary or occupied by the object. So volume, they use liters per cubic meter. Which defines an area for the mass or the matter to fill. And then these combined are how they came up with the formula for density. And density is the amount of mass in an object per a certain amount of volume. Water has a density of 1 gram per cubic centimeter. And the density was derived to be as measured as kilograms per cubic meter. So it's amount of matter inside of a 3D object like a box, and we're trying to see how much matter they can fit in this area. This is an object that people use to look at to equate the formula. And again, the formula is density equals mass divided by volume. And you can also get mass with this by multiplying density and volume. Can you scroll up a little bit more? All right. So here's an example of just equating density. So we have a cake that has a mass of 500 grams, and we divide it by the amount of area it takes up, which is 2,500 cubic meters. And we end up getting 0.2 grams per, I think that's centimeter cubed. I might have messed up on that. So that's just the basic equation for density. And if you scroll up, so what kind of got me interested in density was the fact that I like a lot of astronomy, and I was watching a show and it was telling me how these neutron stars that form, actually, if you were to take 1 teaspoon of a neutron star, which is a collapsed star that's been pressed together by gravity very tightly, 1 teaspoon would weigh 4 billion tons, which is also an equivalent to a mountain. So, and that's all I got.
Wow, very cool. Very cool. Any comments or questions for Paul? I like this cake.
Yeah, it looked good at the time, so I used it.
I really loved how you started off with just a story about Archimedes and the story of him, where, because I hear that before, Eureka, I found it. And cartoons.
Yeah, it's a fun project.
Yeah, I've seen it in cartoons, but I didn't really know actually the background behind it.
He was it was a big breakthrough for astronomy and physics at the time back in which is around 250. Actually, I think it came out in 1200. It was a breakthrough in physics. He actually inspired Newton with some of his stuff, and so there's still a lot more to learn. So, but this was the basic idea that I got from it, and I really enjoyed learning it.
Are you taking physics class right now?
Not right now, but it's one of my next classes.
Oh, got it. Okay. My boyfriend is taking physics right now. So I've been studying with him, and we've been learning mass, volume, density. So everything you're sharing right now, gosh, I just learned this as well.
Oh, okay. Yeah, I'm very excited to continue learning.
Great.
It's a really cool subject.
Very cool. And you will definitely be using math in it as you'll.
Yeah. 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 Physics and I was gonna say these new computers. I'm trying to think of quantum physics and quantum computing. They all use a lot of algebra.
Yeah. Right. Great. So you'll get to see math at play in the science world when you take those classes.
Yeah. Definitely.
Any other comments or questions for Paul? All right, so for those of you guys who haven't done actually, let me stop the share. For those of you guys, and here I am. For those of you guys that haven't done a project yet, or if you missed a project that your group already did and you weren't there, if you guys still want to do it, let me know. You could just work on one individually so I could give you credit. And the student, I think we're on week 15 right now. You only have 3 more weeks of school left. So there's only 2 more weeks left to do projects or to do student spotlights. So if any of you guys haven't had your grade yet for student spotlight or group project, please, you only have 2 more weeks. So the time is very limited if you guys want to do it. All right, so that being said, we're going to move on now in the last hour working on the new worksheet. And the new worksheet is on logarithm functions. So if you could take out your worksheet that I posted up on Canvas. And all right, so here is the worksheet that you should have on Canvas. So here we're going to talk about logs. And as you notice, it's 14 questions. So we see a bunch of logs. So let's talk about it. So they call it logarithm functions, but for short, logarithm functions. For short, it's called logs. We call them logs for short. So logarithm functions are related to exponential functions. And they're related to exponential functions in such a way that logarithm functions are the inverse functions of exponential functions. So log functions are inverse functions of exponential functions. So if you remember, just in this chapter that we've done, sorry, I'm gonna clear my screen real quick. It's so blurry. Okay. I have to hold the phone today because my gadget broke, unfortunately. So if we look at exponential functions, so let's look at an exponential growth function, right? So here is f of x is equal to a to the x. This is an exponential function. And in particular, this is an exponential growth function. So when we talk about the inverse, remember the inverse is where we switch the x's and y's, right? So when we switch the x and y's, so here, this point here is 0, 1. So if I switch the x and y's, the 0, 1 becomes a 1, 0. right? This here is some value, I forget, and then another value and another value. So here are the x's and y's for these. So I'm going to switch the x's and y's. And long story short, when I switch the x's and y's, I end up getting dots that look like this. So these dots will get closer and closer to the y-axis, but it'll never cross the y-axis. Notice this gets closer and closer to the x-axis, but never crosses the x-axis. So it's the inverse. Sawyer, please stop. Stop. So this is what we call the inverse function. So the inverse function is the log function. F of x is equal to log base A of x. Sawyer, stop. I'm teaching right now, I'm working. All right, so that being said, this is the inverse function of this. So that's how they're related to each other. So now let's talk about logs. We've learned a little bit about exponential functions. Now we're going to talk about what logs are. So here in number 1, it says rewrite as an exponential function. So first of all, I'm going to talk about how they're related. So log A x is equal to y. So this f of x, I'm going to just call it y. It's related to the exponential function in the following way. So how it's related is that this is equal. This is, if I wrote log this way, I could write the exact same thing as the exponential function, which will look like a y is equal to x. So this is a relationship between logs and exponentials. This is the relationship between the two. And don't get hung up on these letters because these letters can change. So if I had log, say mw is equal to z, right? So I don't want you guys to memorize the letters. I want you to memorize what's happening here. This will become m raised to the z is equal to w. And let me talk about how I remember this without memorizing the letters. So the way that I remember it is a very cheesy way of memorizing formulas. So what I think about is I think of logs. So log x, right? This is log x. So I ask myself, okay, I think of Abraham Lincoln way back in those days. He wants to chop wood, right? So Abraham Lincoln wants to chop wood, and what do you chop wood with? You chop wood with an axe, right? Or what do you chop a log with? You chop a log with an axe. So how do you chop wood? Well, I'm not a professional wood chopper, but what I know is you start from the bottom. Whenever you're chopping wood, so here's a person chopping wood, right? Sorry, really bad picture. Here's an axe. And there's wood, right? This is wood. Wood. So what you do when you chop wood is you always start at the bottom and then you swing around and then you chop, right? You swing, or maybe I should draw it like this. You swing it around your head and then you chop. You start with your axe on the bottom and you swing it over your head and then you chop. That's how you chop wood. Start from the bottom, the base, swing it over your head and then chop. So here I think of the same thing, Abraham Lincoln chopping wood. Abraham Lincoln chopping wood. That's a hat. So I start at the bottom and then I swing over here. So A, and then swing, the highest I get is to the Y. So when I swing around, I start down and swing around. A, and I swing high into the air, so A to the Y. So the exponent is the highest one here. So A to the Y. And then when I chop, oops, I'm running out of batteries. And then when I chop, I swing it over. So A, swing your axe over, chop. So A, swing it up to the Y is equal to X. Same story here. I start with the base, M. So there's my base. I swing to the other side. So when I swing to the highest point, I get Z. I swing here, and then I chop down, I get equals to W. So it's a cheesy way of remembering, but that's how I do it. So what if I ask you, what is log r y is equal to t? Looking at that log function, how do you write this as an exponential function? Can anyone say? Same analogy. What would you do? What do you start off with?
Start with the R.
Good. So we start with the r, the base, and then what?
Square root T.
Good. Raise it to the t power, the exponent t,
Equals W.
equals to what?
Y. Oh, equal to Y.
Great, equals to y. Good. Right, so you start from the bottom, you swing high to the exponent, and you chop over to equal to y. So a lot of students memorize the formula, but the problem is if you memorize the letters, what if the letters change? Then they'd forget it. So that's why it's better to remember the relationship just by thinking start for the base, swing over to get the exponent, and then chop down across to get the answer, right? So great. So now let's go ahead and look at number 1. So now it says rewrite as an exponential function. So go ahead and try to swing your axe to change this to an exponential function.
I have another way of doing it as well.
Okay. Let's finish this one, Garrett, and then I'll have you share your other way of doing it. Is that okay?
Sounds good.
Okay. I love that there's multiple ways of doing it, so I can't wait to hear yours. All right, so where do we start off first? There's all these numbers. What do I start off with first?
2.
Okay, 2. So I start with the base, and then what?
Exponent -5
Great. Exponent -5
equals to 1/32.
1/32. Perfect. And that's your answer, just rewriting it as an exponential function. Does anyone have any questions with that? All right, Garrett, you're up. I'm going to spotlight your video. Okay.
I'm going to use something else as an example for a second. So remember when we were doing like exponents and stuff, or multiplication or division, right? There's an inverse operation. So here the inverse of the square would be the square root, right? We would take the square root of both sides. I can't do this upside down, right? Over here, to get rid of the square, we square both sides, right? And then the square and the square root cancel out, the square and the square cancel out. We can do the same thing with log and exponentials. So if I have, say, log base 2 of 5, or t equals s, the inverse of a log is the exponential. So what I'm going to do is I'm going to use this as the exponent of that base. So here my base is 2. So I raise 2 to this power, and then I'm going to raise 2 to the s power. And just like with the square and a square root, these operations right here are inverses, so they cancel out. And now I'm left with t. I mean, if I rewrite that, that's t 2 to the s. And this was log base 2. Right? And if we do that same thing that she was talking about, we bring this guy over and we chop it, right? We'll see that we'll get a 2 here and the t. And similarly, if I say I have 3x equals y, if I want to write that as a logarithm, well, the inverse operation of an exponential is a log, so I'm going to take log base 3, because my exponential base is a 3. I'm going to take log base 3 of both sides. Right? The log and the exponential, those cancel out, and I'm left with x equals log base 3 of y.
Very cool.
Okay.
I've never seen it that way before.
Really?
No, I haven't. Very cool.
That's how you usually do it for like differential equations later on.
No, yeah, I haven't seen it. Yeah, you're right. I never tied the two together. So great.
Yeah, so they're inverse operations. Just like say I have 2x equals y, right? How do I get rid of multiplication? I do the inverse, division. Right? If I have x minus 3 equals y, how do I get rid of subtraction? I do the inverse, I add. Right, so all of these, it's just the inverse operation. How do I get rid of something? I do the inverse of it.
Great. So if you start off with logs and you want to get rid of logs, then you do its inverse, which is take the exponential, meaning putting it to the base 2, right?
Mm-hmm. So you'll have 2, raise this whole thing to the base 2 power. This will be now the exponent. This will now be the exponent, right? If I put a 2 down here, a 2 down there, those cancel out, and I'm left with t 2 to the s.
Cool.
Or vice versa. I take the log of both sides if I'm trying to get rid of the exponential.
So if you start off with log, to get rid of a log and make it exponential, we do its inverse, which means you take the exponent. Yeah, okay. Cool, sounds good. Thanks, Garrett. So there you have it. You guys have 2 ways of doing this problem. The Abraham Lincoln chopping an axe way, or thinking of it probably more mathematically, as Garrett pointed out, is to take the inverse of that function, and the inverse of the function of a log is an exponent, and the inverse of an exponent is a log. Great. Thank you, Garrett, for showing us that. If you guys have more questions about that, you could feel free to ask Garrett. Now let's go ahead and look at number 2. It says evaluate this. So notice we don't have anything, it doesn't equal to anything, right? So if it doesn't equal to anything, you go ahead and put down equals to y. So if it doesn't have an equal to a number, just put down equals to some letter y, if it doesn't have it. And then now, go ahead, after you do that, go ahead and rewrite that as an exponential. So either think of it as the way Garrett did it, where you take the base 3 and then you put the base 3 on both sides, or go ahead and do it the other way that I showed you with, which is thinking of that swinging an axe. And what would you guys get? So same thing as you guys did up here.
Equals 1 to.
I'm sorry, can you say it again?
It's going to be 3 to the power y equals 1 over 27.
Right, good job. Right, so either you think of it as the 3 here, swinging it over to the y equals to 1 over 27, or you could think of it as raising both sides, putting a base 3 on both sides. If you put a base 3 on both sides, then these two would cancel out, so you get 127 equals 3 to y. Whichever way is going to work. Okay, so it says evaluate. So once we have that, so this question says just to rewrite it as exponential. This one says to evaluate. So when it says evaluate, you actually want to solve for what is y. So evaluate is solve for y. So when I have 3y is equal to 1 over 27, I'm like, oh shoot, now how do I do this? Well, how you do this is notice that this is a base 3, and this is a base 1 over 27. And there's no exponent here, right? And you could think of it as an exponent of 1 if you want. But anyways, so what you want to do is you want to rewrite this, rewrite both sides with the same base. So rewrite both sides with the same base. This is a base 3, so there's my base 3. 1 over 27, how do I write 1 over 27 with a base of 3? What would base of 3 raised to what power will give you 1 over 27?
To the third.
Close, very close. 3 to the third will give you 3 times 3 times 3 will give you 27, right? But since
-3.
Perfect. So because it's 1 over 27, we want to put a -3. Great job, both of you. Right? So the 27, we realize, okay, 27 does have a base 3. If you write 3 to the third, it'll give you 27. But since it's in the denominator, that you want to make it a -3 because it just flips the 27 to become 1 over 27. So now that you have, so first you write it as exponential, right? So exponential. Then you rewrite it with the same base on both sides. And then the last step now is, since the bases are equal, or since the bases are the same, then the exponents are equal. So here, since 3 is equal to 3, the bases are the same, then you could look at the exponents, and then you could set the exponents equal to each other. So the exponent y is equal to -3. And there you go. You now have your answer. Kind of cool, huh? So again, let me say this again. First step is to write it as an exponential. So you could chop the wood, use your axe, or do the inverse. So get it to an exponential, set the bases equal to each other. Once the bases are equal to each other, then you can set the exponents equal to each other. And that's it. You might be wondering, well, what if we can't set the bases equal to each other? What if this is like 1 over 29, right? 3 to whatever power will never give us 29. Well, that's where we're going to have to use logs. And we'll do that in another problem. But if you cannot set the bases equal to each other, this is the easy way of solving the problem, then you're going to have to log both sides, and we'll talk about that later. Okay, any questions on number 2? Let's look at number 3. So go ahead and do the same thing. Now you have equals to a number. So it says solve for x. Let me give you guys a chance to work on that. Alrighty, so looking at this, who would like to help me out? What do I do first?
So it would be 100.
Okay, so we start with 100, great.
The power of 1 over 2
Power of 1 over 2
equals x.
equals x, great. So you start here, swing it over, and did that. Great, so we just wrote this as an exponential function. Is everyone okay with that? Alrighty. And now we want to solve for x, right? Well, x equals to 100 to the 1/2. So here, we don't have to do anything fancy such as this. X equals to a number already. So let's just simplify this. What is 100 to the 1/2 power? Does anyone know?
10.
10. And how did you get 10? How did you get 10?
I put 100 over 1 and just multiply both fractions, and I divided them.
I'm sorry, say again. You put 100 to the 1.
So I put 100 over 1,
Uh-huh.
and I multiply both fractions, 100 over 1 times 1 over 2, which gave me 100. No, wait. Hold on.
You are correct. The answer is 10.
The answer is 10, yeah. I'm just wondering how you got that. So wait, we explain it to people who are wondering.
Oh, no, I just put 100 over point to the power of 0.5.
Oh, so you, okay, so Ronaldo put 100, raised 1/2 is 0.5, so you plugged into your calculator then, right?
Yeah.
Okay, great. So he plugged into the calculator 100 to the 0.5, and that'll give you 10. Does anyone know y equals to 10 besides plugging into the calculator?
Isn't it because 10 squared equals 100?
Right.
You're on the right track.
You're on the right track. So 100 to the 1/2. So do you want to explain it, Garrett?
So remember a 1/2. Do you guys remember what a fractional exponent turns into if we were to rewrite it another way?
Decimal.
Particularly with the radical sign. You guys remember that? So yeah, she's writing the generic form over here. So remember, the denominator comes out, and it comes outside of the radical. So if we were to write that as a radical, we'd have the nth root with the radical sign, a to the m. So in this particular case, right, my m is 1 and my n is 2. So the 1/2 is the same thing as the square root of 100. That should ring some bells. We did this earlier in the semester. Is that coming back to you guys?
Yeah, I understand now.
But you are correct. The answer is 10. I think that maybe it's just in tuned in your head and you're just like, oh, I know that. How do I know that? I don't remember, but I know it's there.
All right, thank you, Garrett. All right, so we convert this exponent to a radical. And how do you convert exponents to radicals? What Garrett just said, right? The denominator is the index. So here, if the denominator is 2, you pull that out. Square root of 100 is just 10. And that's why it's 10. Or you can plug it into your calculator, but I'd rather have you guys understand why. Great, awesome, possum, thank you. Of course, you have more chances to work on this on your homework, but at least you guys have something to start off with. Number 4, fill in the missing values to make the equations true. So you see a bunch of logs. So before we go into number 4, I'm going to talk about, in order to answer number 4, we need to talk about the properties of logs. So whenever we talk about something new, we always want to talk about what are its properties. We call it properties or we call it rules, whatever you want to call it. But they're basically asking, so with logs, what can you do with them? When you add and subtract and multiply and divide logs, what happens, right? And this is the rule. The rule is this. If I have log, so first rule, if I have log of A times log of B, and notice there should be a little base here, but I'm just gonna not include it in right now just to have a shorthand way of writing it. So whenever you write log, there's normally a base here. And I'll talk about when the base is invisible, why it's invisible. But right now, just I'll say log A times log B. So when I have log A times log B, when you're multiplying two things, I'm sorry, not multiplying, it's adding. When you're adding two logs, what you do is, if you kind of think of an accordion, if you remember an accordion, right? Here's someone playing the accordion, and then it has some springs, right? And it could go small and big, small and big. I think a log property says that. Here's the accordion being stretched out, and now you could condense the accordion to have just one accordion. So here's two accordions, and then when it comes together, it just becomes one. So two accordions, when you bring it together, if you're adding, this becomes A times B. So A times B. The second property is if you have log of A minus log of B. Again, this is the accordion that's being stretched out. There's two accordions. But if you condense it, you put it together, there'll just be one log. And when you condense it, you'll be doing A divided by B with one log. And if you think of exponential functions, if you remember exponential functions or exponents, whenever we did the product rule of exponents, if you remember, recall, so I'll just put it here, recall, if you had A to the M times A to the N, when you had exponents, what do you do with the exponents? You add them. When you had exponents where it's A to the M over A to the N, what did you do with the exponents? You subtracted them. So you're going the opposite direction. Notice here's the stretched version, and then when you condense it, it becomes this. Here's a stretched version, and you condense it, becomes this. It's exactly the same thing, but it's reversed now. So this is with the exponential rules. So log rules are exactly the same thing, except it's the reverse. So if they're being added, if they're stretched out being added, when you condense it, you multiply it. When they're stretched out, they're being subtracted, but when you condense it, it becomes division. So they're similar to exponential rules, but just the reverse. And then the last but not least rule is this. And this last but not least rule is really useful when we start solving equations. If I have log a to the b power, if I log a to the b power, what I can do is this exponent here, I can move that exponent to the front. So that exponent, I move it to the front and I put b is now multiplied to log a. So the b now becomes the coefficient or being multiplied with log a. So these are three very, very important properties of logs to remember. 1, 2, and especially the third one. We'll see the third one showing up in solving equations shortly. So now let's look at using those properties. Let's look at number 4. So notice in number 4 here, I have log 7 plus log 2. And the base is 5. Notice all the bases are 5. So that's fine. We just leave it the same. But log 7 plus log 2, what do you do to condense this? So using these properties, what do we do?
You multiply 7 and 2.
Good. So you multiply 7 and 2. So we end up getting log base 5. The base doesn't change. The base stays the same. And 7 times 2 will give us 14. Okay, so you multiply 7 and 2. Is everyone okay with that? All right, let's look at part B. So part B here, I have a blank here. Log 11, oh, all of them have base 4, right? So log 11 minus log blank is equal to log 11 over 5. What do you think goes in that blank?
5.
5, right. Because we're using the second property of log. And here, log A minus log B is log A over B. So this is 11 over 5. So you would have a 5 in here. Does anyone have any questions with that? No questions?
How did you get 5? Like,
Okay. How do we get 5?
yeah.
Great question. Because if you notice here, it equals to log 11 over 5. So look at the properties of logs, the second one. When you have a log of a fraction, it's the top, it's log A minus log B.
Oh, okay.
Because the 5 is here, the 5 is there.
Okay, I get it now.
Okay, all right, great. Let's look at part C now. I have 2 log 5. So part C, hint, hint, you're going to be using the third rule. So 2 log 5. So of course, there's a base 7, right? This base 7 is always there. What do you think we're going to do with this 2? So we're here in this problem. We're going to start, it actually starts here. We have a coefficient in the front. If you have a coefficient in the front, you could bring it over and make it an exponent of that A. So here, this 2 in the front, what do you think I'm going to do with the 2 in the front?
Do you put it over the 5?
I'm going to make this equal to log base 7. I have 5 to the second power. So I bring the 2 and I bring it over to the exponent. And what's 5 to the second power?
25.
Right, 25. So your answer here is log base 7, 25. So this 2, we brought it as an exponent to the 5 using the third rule of logs. So 5 squared becomes 25. The bases, notice, never change. A base just stays the same. All the bases are the same here. So that becomes 25. Is everyone okay with that? Any questions? All right, and again, you'll have more chances to work on this on Alex to become good at it, right? Now let's look at number 5 and number 6. Notice that number 5 and 6 have a log here and a log here, or a bunch of logs. This is one log. This one says to expand it. So again, if you think of the accordion starts off with one log here, and now you want to expand it to make it a bunch of logs. Notice in question 6, it's a bunch of logs, and then they want you to condense it to make it a single log. So we need to know how to do both, to go to stretch it out, but also to condense it. So the accordion goes out and in, and to do that, we use these 3 properties of logs. So let's look at number 5. So if we want to expand it, I have log y divided by z cubed. So which properties, property 1, 2, or 3 deals with a log of a fraction?
2.
Number 2.
Good. So number 2 has a log of a fraction. Here's a condensed version. We want to expand it. So to expand it, we have to do log of the numerator minus log of the denominator. So go ahead and rewrite this. Log of the numerator minus log of the denominator. Is everyone okay with that?
Mm-hmm.
Notice we don't have any base on here, right? So when there's no base in here, I'm just letting you know, if there is no base written, assume that the base is 10. So whenever you have like example, if you have like log of A is equal to B, this is exactly the same thing as saying log base 10 A is equal to B. So in mathematics, there's certain things that are invisible, right? Like they assume that if it's not there, then it's something. So when the log has nothing there, it's assumed that's a 10. So when you look at your calculator here, when you push log in here, there's nothing on the base, you can assume that that base is 10. So the calculators work off of a base 10. So just FYI, there's always a base. Every log has a base, but if it's not written, it's assumed that's a 10. Anyways, so that's just letting you know why there's no base there, because it's assumed it's a 10. So here I have 2 logs, so we stretch it out, but then I notice there's a 3 here. What can I do with this exponent?
Move it in front of the 3 in the log.
Wait, so that's the third property, right? If you have an exponent, you can bring it outside to the front. So here to expand this, because expanding means to make it stretch out as much as possible, we get log y, the 3 minus, I'm going to bring the 3 out to the front, minus 3 log z. And that becomes your final answer. So when you have a fraction, you can stretch it out using the first property. And then if you have a exponent, you can stretch it out again by bringing it out to the front. Does anyone have any questions with that? All right, and I'm sorry for going fast. Again, I just want to be able to do a few examples with you guys so that you'll be able to do your homework. And if you have questions, you can go back to these videos. But again, it's not enough to learn the material. You have to practice it, right? Question number 6. Question number 6 is now we want to condense it, right? So like the accordion that stretches in and goes out, here's 3 logs. We want to make it into 1 log. So we want to make it into 1 single log. So now we're going to go the opposite direction. So first of all, I'm going to look at one of them at a time. Looking at this, I have a 1/2 in the front. What should I do with that 1/2? What property should I do when I have a coefficient in the front?
3.
I have the third property, right? When you have a coefficient in the front, you bring it up to the exponent. So when you condense it, this 1/2, you want this to be up here. So you have log base m. So here the base is m, right? Y, and the 1/2 is now attached to the y. The 1/2 is now the exponent of y. Do you guys see that?
Mhm.
Plus, let's look at the second one. Go ahead and rewrite that. You have a 6 in the front. So what does that become?
Log base n c to the 6th power.
Great. So you put the 6 as the exponent of z. Perfect. Good job. Minus, and then minus this. There's no coefficient, so I'll just write it as is because there's no coefficient. Is everyone okay so far?
Yeah. Mhm.
So far, all I've done is put the coefficient up as an exponent. But I'm not done yet, right? I want to condense it. So there's 3 logs. I want there to be 1 log. So now I'm just going to look at 2 at a time. This plus this. So just look at 2 at a time. When I have adding, which property should I use to condense it? Property 1, 2, or 3?
1.
1.
Good. So property 1 says if you have 2 logs that you're adding, you can condense it by making it 1 log and you multiply those 2 items together. So let's go ahead and do that. So I have log base m. So what do we do with these 2?
Multiply that.
Right, great. So when we multiply, we just get y to the 1/2 and z to the 6, right? You multiply, it just becomes sitting next to each other, right? Minus log m of x. Log base m x. Now, how do you condense these 2? What property do you use when you have subtraction?
Number 2.
Great. Number 2 says if you're subtracting 2 logs, you could write it as a fraction. The first one's the numerator, the second one's the denominator. So let me give you guys a chance to go ahead and write that answer. So here, what do we end up getting? Log base m, and what did you guys get? Anybody?
It'd be y 1/2 z6 over x.
You guys agree?
Yes.
Yes.
Great. And I would just emphasize just probably putting parentheses around there just so that it looks that it's very obvious that this log, this quantity is attached to the log, right? Great, perfect. So this is the answer. Good job. So whenever you write logs, just let you know there's always a base. So if it's not, the base isn't there, you can assume it's 10. But if it is there, you need to write it down. And log is always attached to some quantity. So you can't have a log just sitting by itself. It's meaningless. It has to be attached to something. And whatever it's attached to, I tend to put it in, if it's a bunch of things, we put it in parentheses. So we know that that whole thing is being attached to this. Because if you don't write it as parentheses, you think it's just log multiplied by something else. It's not log multiplied by something else. It's log of this thing. They're attached to each other, like a head and a body, right? They're attached to each other. Great work on that. So number 5 and 6 are pretty challenging because you have to use all of the rules. You can expect to find number 5 and 6 on a quiz or on a test, right? Last but not least, I want to do number 7. So number 7 here says, use a change of base formula to compute this log. Round your answer to the nearest 1,000. So that's a big hint when it says to round it, is to use your calculator. You have to use your calculator on this. But remember what I said, on your calculator, the base here is log base 10. So the thing is, on the calculator, log is log base 10. Right? If you plug log 5, if I put log 5 here, log 5, and I press enter, I'm gonna get this answer, which is the incorrect answer, because this is log base 10 of 5. But we want log base 3 of 5. So the question is, how do we do that? So how we do that then is the formula where they call it the change of base. Let me see real quick. I just want to make sure I'm teaching it right before I do this. Okay, so the change of base formula is this. Change of base formula. So how do we change this? Because if I want to plug this into my calculator, I have to change this to base 10. So how do I do that? So the formula is this. If I have log AB, so any number, to do a change of base, this is equal to log base 10 of B divided by log base 10 of A. So this is your formula for change of base. So in other words, if you want to plug something like this in your calculator, you're going to plug log of 5 divided by log of 3. So here in this problem, sorry, I ran out of space here. So log 3, 5. I'm going to change the base to log base 10 of 5 divided by log base 10 of 3. And I'm going to plug that into my calculator. So keep in mind, this is not 5 divided by 3, right? It's log of 5 divided by log of 3. And now that we have the base 10, we can now plug this into our calculator. So when I plug into my calculator now, I get log, assuming the base is 10, 5, close the parentheses, divided by log, again, assuming the base is 10, of 3. And then I press enter. And here is the correct answer. And they say to round it to the nearest thousandth, which is the nearest 3 decimal places. So 1.464. The third decimal for the third place is 4. You'll notice the number after that is 9, so I'm going to round up. So this becomes 1.465. So when you're rounding to nearest thousandth, this is 10th, 100,000th place. So the answer is going to be 1.465 as your final answer. Alrighty, does anyone have any questions? I wish we had more time so I could let you guys do U-tries where you guys try different sets of problems that are similar to this. Unfortunately, we don't have time for that. So you guys will be practicing on Alex instead. So these 7 questions are, I want you guys to finish at least 7 topics by Sunday. So by Sunday, finish at least 7. Garrett, again, is available Monday to Thursday, 12 to 4. So if any of these questions are like, what, I forgot how to do it, feel free to contact Garrett on Discord, or you can message me and I'll be happy to help you as well. Come Monday, we're gonna do numbers 8 through 14. So I would love for you guys to finish up to 7 by Sunday so that you won't have a lot to do next week. I don't want you guys to cram your work. And better yet, if you can, do it right after class while it's fresh in your head.
And if you don't mind, I just want to give like a brief explanation of what exactly a log is, because you see it and you're just like, okay, I get it. It's like the inverse of exponents, but I don't get it. Like, what's the point? Do you mind if I go ahead?
Yes, go, please.
So this only really works with like an exact one. So I'm going to use an example here. So log base 2 of 8. So we can rewrite this, right? And we can see what that is. Another way to kind of think about it and what the log is doing, it's asking the question, how many times can we divide by that base until we get the value 1? Okay, so here, if I divide 8 by the base 2, I get 4, right? Now, if I take that again, 4 divided by 2, I get 2. take that 2, divide by 2, I get 1. Okay, now I got that 1 that I wanted. How many times did I do that? How many times can I divide by 2 until I get to 1? Well, I started at 8 divided by 2, that's 1, 2, 3, right? So I can divide 8 by 2 3 consecutive times. And so here, the answer to this is 3. And if you notice, if we rearrange it, right, I will have 2 to the 3rd to the 8. And is that true? It is true. Okay. So kind of a little bit of what we're doing when I say like log of 20. Well, remember it's base 10. And kind of a way to think about this is how many tens are there, right? How many digits in a way, ignoring the first one. So here I have about 1 digit, right? If I do say log 10 of 300, that's going to be approximately 2. Because I have 10 times 10 will give me 100, which 300 is a multiple of 100, right? 20 is a multiple of 10 to the 1. If that kind of helps. So here we're kind of just asking like how many digits. This only really works with a perfect example, but you can kind of get a rough understanding. And this has a huge application, and this is why I bring it up, in computer science, because we deal with base 2 a lot, because it's binary, right? 1 or 0, 1 or 0. We only have 2 options. So say I have like a list of numbers, and I'm trying to like sort this number. There's different ways of sorting it, but one of them is splitting it in half, seeing if it's sort that half and sort that half. And so I'm dividing this into 2 groups, and then I divide that into 2 groups, and I divide that into 2 groups, right? And so if I want to know how long it's going to take for me to sort this, well, it's going to be log base 2 of the length of this thing. Say it's n items that I'm sorting, it'll be log base 2 of n, because I'm constantly splitting n into 2 groups. I'm dividing by 2, dividing by 2, dividing by 2. How many times can I divide by 2? That'll be log base 2. I don't know. Does that make sense to you, Nancy?
Yeah, that makes sense. I like
Does
that.
that make sense to you guys? I know
Yeah,
it's a
I
little
got it.
weird.
Yes, it makes sense. Thank you. It makes sense.
Yeah, so it's kind of like the opposite, like we said, of exponentials, right? When we do like x squared, it's what's the value if I multiply the same thing over and over again? Well, here I'm asking, what do I get if I divide by the same thing over and over again?
Right. So if we looked at that problem we just did, log base 3 of 5, even though it's not a perfect, you can't divide into it perfectly, you could do it once, right?
You can do it once and then a little bit afterwards.
Yeah, and that's why the answer is 1.465.
Exactly.
Right, the problem what we just did, because you were able to divide it by itself or by that number once, yeah.
You can divide it by it once, and then you can divide it by a fractional amount, right? Some small part of it.
Right, with some leftover, right, exactly.
Mm-hmm.
Great, thank you, Garrett. I love getting another perspective on it. So great, thank you.
It took me a really long time. I've been dealing with logs, we'd learn about it, and you're just like, what are they? And it didn't click until this. It's called a binary tree, where it's a tree and you just split into 2 every time. That's when it clicked. It's like, oh, it's just how many times can I divide by that thing, that base? How many times can I divide by 2 or 3 or whatever it is?
Right, which is the inverse of exponent, is how many times can you multiply by itself. That's cool.
Yeah.
Very cool.
It all connects. It all connects.
And I love that you come from a computer science background, so you can show the application, the long-term application that what we're doing. Right. Very cool. So again, just a reminder to you guys, the quiz is open at 1 o'clock today for the quiz today from for the previous chapter today up until tomorrow until 11:59. The homework is open right now for this chapter on logs and do up to 7 of them for next until Sunday. And then come Monday, we're going to finish this. And then next week, we'll also have a quiz on this as well. And I'm trying to figure out when the next exam would be. I might have the next exam be sometime next week as well, since we would have finished both chapters. But I'll keep you guys posted based on where we're at. But I'll let you guys know as soon as I figure that out. All right, and Stephanie, I see your message, so I'll look into that. Does anyone have any questions for me in the next 4 minutes? All right, no questions?
Oh, I wanted to say, on Alex, it says chapter 9, but it does have the topic of chapter 8 on there.
Are you Math 130 or Math 140?
Yeah, Math 130.
Math 140 or 130, you guys should be on this is chapter 9, I believe, in 140. Or I'm sorry, in 130.
No, yeah, but like for the online quiz, it says that it's chapter 9 when it's supposed to be chapter 8, but it has the topic of chapter 8 right next to it.
Got it.
Just want to let you know.
Thank you. I'll go ahead and change that on there for Math 130, right?
Yeah.
All right. I mistyped the chapter. Thank you.
I kind of figured that out, and I just wanted to let you know that it was a miserror.
Great. Thank you.
Yeah.
Jessica, I see. I haven't checked my Canvas email yet, but I will. Jessica, what did you write on your? Oh, and for anyways, I need to leave right now. Feel free to do so. So it was great to see you guys. I'm gonna stop the recording at this point.
Oh, I just had emailed because